I have made a very simple smart contract. I am picking a good Evernode instance to deploy on. I need a key pair to identify myself with my Evernode instance. I also need EVRs to pay for my instance. Now I am deploying with authenticate. When we get our instance, we also get a domain. That domain can be used, but we can also use our own. When I have deployed, I get a WebSocket port, also known as user port. I also get 2 TCP ports, the one you see here plus the very next one in the port range, meaning 36527 and 28 in this case. Here I can see that the contract bundle has been deployed successfully. During deployment, these 2 files were created. This config file shows you the UNL list, which right now only contain my single instance as I only used one instance. I deployed an Evernode Docker container with a GUI this time. It might not be the most optimal thing to do, but it is very pedagogical. Now I am inside my Evernode instance. Here is my Evernode smart contract. The seed folder is not a subject to consensus, so software that you have in here can run without being affected by it. My contract has executed the word hello into this file. As you can see, this log file was saved in an Ancestor folder to the state folder. Now I'm in the state folder. This folder is a subject to consensus. The smart contract have executed the word hi into the state log file. Of course, consensus doesn't matter right now, because this is a single instance and not a cluster deployment. I am now in the log folder of the contract. This is how the ledgers look like. You can decide yourself how often the ledgers should close. Now I will look at the contract error log. By tailing logs, I can see what happens in real time and develop and try my contract easier. Now I will tail the ledger to monitor it as well. So, now I will make the contract stack high to the log file every time the ledger closes. And when I tail it, I see that it works well. I will now create an Evernode cluster. I am adding my preferred instances to this text file. I have a very simple script. I am deploying to a cluster of 3 instances. In my config file, I can see that I have 3 instances in the UNL. This means that the consensus is between them. Now I will connect to all 3 instances. I use a GUI because it's pedagogical, but it's smarter to not use one. I will tail the standard output logs to see what my contract do. I will also tail the HotPocket itself to monitor the ledgers. As you can see, all instances are synchronized with each other. Now I will work with the smart contract in real time. I am now creating a message that this instance will keep to itself. The message is only turning up on one instance, not the others. Let us create a file in the outside of the state folder to see what happens. As you can see, it has been created right here in the seed folder. Now I will break the consensus by creating a file in the state folder with my smart contract. As you can see, the ledger halted and the consensus braked. Start off by grabbing a nice Evernode instance to use. Make sure you got EVRs in your wallet and deploy your instance. This is your WebSocket port. It is used to communicate with the HotPocket ledger. And this is your TCP port. An Evernode instance always get two of these. The one listed and the one after, in this case 36525 and 36526. For pedagogical reasons, we use a GUI in this example. But it is always wiser to not do it, as it uses a lot of resources. This is the contract folder. Let us tail the ledger log to see it in real time. This is the seed folder. It allows long-running processes. This is the state folder. It does not. The contract in here executes between created ledgers. Here is the very simple contract. It is saving the word hello to the seed folder and the word hi to the state folder. It seems to be working properly. Now let the fun begin. I will start off by installing a dependency that I need for creating my decentralized app. I am cheating a bit by grabbing the code from the internet. As this is a long-running process, it cannot be in the state folder. For that reason, I am placing it in the seed folder. My second port was 36526, so I am making sure this app listens to that port. This is the page people will see. We are using Node.js to run the website. And here it is working well. And here it is available for the public. You can use your own domain if you want to. You can also remove the port number from the address field and enable SSL. I shut off the server by hitting Ctrl+C. Let us run the server as a daemon in the background. You can see the process in this list. Let us kill it to see if it stops. It sure stopped, but we are not finished yet. Now it is time to write data from the ledger to the app. I am starting off with just a sample text that executes on my optional round time, in this case, every 2 seconds. I am now adding some random HTML code to write into the website. Time to cheat again. I will now grab some code that fetches information from the ledger. The smart contract is now sending us the contract ID on every ledger close. I will now add some more data from the payload. And there you have it, a decentralized application on its own private blockchain. Well, almost decentralized. To make it truly decentralized, you need to run it on multiple instances. You can decide how many. You can even allow other people that you don't know be a part of your Evernode cluster. The abilities are endless. The secret sauce is the consensus engine. The best part here is that your applications can be distributed into multiple locations across the globe. allowing for true decentralization.